So, hi Lenny, welcome back.
Hi, Adam. It's nice to be back. It's nice to be still alive.
Yeah, still alive. So, you remember your last episode? When was it?
I do. It was, well, it had to be like in early May because on May 22nd is when I had my back surgery and it was
Exactly.
really scary.
It was June the 13th, and it was in episode 92. And just to know the two-factor authentication in my podcast. So, you still remember what was your first computer?
Yes, I do still remember what my first computer was. The Commodore 64. Or my first computer was the VIC.
Not right.
My first computer was VIC 20. The first computer.
Exactly. So okay, now you are Lenny. No, now we are talking. So now, how your surgery went? So everything okay? You look like a human, so everything seems to be right. Everything works.
Yes, I'm still alive, which I was really worried about that I will not come out alive from this, which is unsubstantiated, but still. Um, the doctor told me that I went in right on time because he said that if I didn't do the surgery, there would be more nerve damage than there is now. There was nerve damage. He said there was. It was very slight. Uh, I don't really feel like I had any kind of nerve damage, but I believe the doctor, but he said I'll make a full recovery. And my wife is mad at me because my doctor said not to mow the lawn or pick up any yard waste until the next year. So my wife is very mad at me because before she's like, oh, after a month or 3 months or 2 months, you'll be able to do the yard work again. And now I come back from the doctor and she hears that I can't do the yard work for the rest of 2020. So she's
but
like,
in your case, I will pick another doctor. Maybe you get extension to 2022. With the. So
I wish I want to help my wife with the artwork.
It was different. You can, for instance, try to program a robot or something like this. So this would be useful help in the household, or do some blinking lights with Raspberry Pi for Christmas. Also nice work, right?
I know.
Very useful. So you are a grounded pilot, right? So it's over with flying, or what's the situation?
Well, I actually technically went back to work in September.
Oh.
But unfortunately, my airline decided to announce in August that they're shutting down at the end of September. So my airline has shut down at this point, and obviously nobody is hiring. I've been trying, for a few months, even before my airline shut down. I've been trying to figure out what my next step would be. And unfortunately, all the aviation business is pretty dead. If we wanted to move somewhere from Lincoln, I could probably get an aviation job, but that's not in the cards for many reasons. And so right now, my career has been like truly upended. My life, it was kind of hard psychologically because once the airline really announced that they were shutting down, basically my aviation career, it's either on hold for at least 5 years or completely gone at this point because I'm getting old, and when you start a new airline, you start from the very bottom, and that requires many days away from home a month. Most of the month I'd be away from home, and I don't want to do that at 50 years old. I really don't.
Okay. And so I think the last time I was at the airport was probably January or February. So it is like is almost no one in the airplane. So what's the situation? So it's like the traffic cut a half or even less. So what is this?
Well, my last flight was May 1st.
Okay.
And during the month of April, which I kind of flew somewhat, the airplanes, I fly 50-person airplanes. There was 1-2 people
okay.
in the airplane. The airports were completely empty. Everything was shut down. But apparently in the U.S., over our Thanksgiving holiday, we had over 1 million people which is about 50% of normal
Okay.
that's traveled in Thanksgiving. Again, I haven't been traveling or doing anything since May 1st.
So okay, so but you are no more a pilot anymore, or is it on hold? And you restarted your second career, which was actually more and more, or was a leisure almost activity. What is so? What are you doing right now? You are a programmer, right? Again.
Yeah, yeah. So my once a pilot, always a pilot. Even before you're a pilot, once you're getting your first pilot certificate, uh, even when I consider somebody a pilot when they solo, when they first get in the airplane all by themselves and do those three takes off and landings. That is a key point, a key moment in a pilot's life. That's when you become a true and actual pilot. So I'll always be a pilot. I am no longer a commercial pilot or an airline pilot at this point, even though I have my certificates. They don't expire. So as a career, it's on hold, probably on indefinite hold, unless something really, really drastic happens. So I was forced to my second career. My first career was a violinist. My second career was a programmer, and my third career was a pilot. So now I was kind of like pushed into resuming my second career full time. So I do want to talk to you about some interview experiences that I've had lately, if that's what you'd like.
Yeah, sure. So, but you are back to Payara, right?
I am, but I want to tell a story how that wound up happening.
Yeah, this is, of course, it's interesting. So go ahead.
Very, very, very interesting. So the first thing when I realized that flying was no longer an option and I needed to figure out how to get back into programming full time, I did talk to Payara, but it takes a while to get anything of that on squared away. But I talked to other people and I tried to get some interviews lined up. I talked to some hedge funds back in New York with some friends of mine that I know for a long time. And basically, what I found out is that all the hedge funds, they want somebody on site, so remote wasn't a possibility. Maybe they changed their mind now, but this is a different story. Back then, which was not that long ago, maybe in about September timeframe, everybody was saying that yeah, they're going to need somebody on site, COVID or no COVID, so no go for that. So I tried Google. I have a friend at Google that recommended me for a job at Google. So I basically what you do at Google is you apply a few times for some jobs that seem to be a match for you. So I applied for 3 jobs at Google, and within a day or two, I got rejected for all 3 of them, even though I had an internal recommendation. So that didn't work out so well. So next, that same friend who recommended me at Google, he's like, "Look, I got an email from a recruiter from Amazon. So since I'm not leaving Google, I'll send him to you." So now, so I got this. So I got in touch with this Amazon recruiter, and she's like, "Yeah, we'd love to interview you. We saw your resume. That's fantastic. We have plenty of jobs." So the first thing that they did is they gave me an online coding assessment. I don't know, Adam, have you dealt with any of that? Have
No.
you? No. So that's the first thing that they do. It's there's a few of those now that I found out. There's a few of those coding assessments, and what they have you do is write a program that does some kind of an algorithmic thing, like figure out a depth of a binary tree, or there is some kind of there are these things that you study in computer science
Mm-hmm.
class. I don't know if you like remember any of that.
Yeah, I remember that, but I think it could be really hard. I mean, who knows, all the algorithms,
Well,
right?
that's what I'm getting at. And the Amazon interview consisted on doing 2 of these problems. And I guess there's a cottage industry now that deals with this. So not only can you type in a program, but they have like on the website, right on that website, they can compile that and they can test it. So they basically run tests against your code, and they said that 1 or 2 tests passed and 15 failed, and they don't tell you why they failed or how they failed. So it's kind of crazy. So I was able to get
This
that.
remembers me.
Go ahead.
Are you actually a Sun certified Java programmer?
I'm not. No.
I did the certification. I think was 1999. And what I really remember is that there was a multiple choice, but you had no idea how many the answers are right. And it was really hard because they were like the corner cases of Java syntax. So this was really hard. And the first certification I failed, and then the second I passed. But what I find out back then is there was a trainer at Sun Microsystems who'd actually teach the courses for Sun certified Java programmer, and he tried I think like 15 times and was never successful with the with the certification itself himself.
Right. So by some miracle, I was able to finish the two problems with about 60% of the tests passing because I couldn't figure out what was wrong with the other test. And submitted it. And then, so I was waiting for the next step. So there was like no next step, no next step. So I contacted the recruiter again. I'm like, what's going on? And she's like, oh, we're having some technical issues. I think we lost your tests.
Oh,
So I'm like, oh, great. Like, are you going to make me do this again? Because I don't think I can, or nor am I willing to do this. Or are you going to like go to the next step?
and you remember what it exactly was? What kind of algorithm you had to implement?
One of them was figure out you've got a like a unbalanced binary tree or something like that,
Okay.
and you have to figure out the deepest the deepest part of the tree.
Mm-hmm.
So it's basically loops and not even recursion, basically loops and checks and
Mm-hmm.
saving state. It's not very. This is something that my brain just shuts down when I see something like that.
And this
So
is like a Java program in Java or in what?
yeah, they have you pick a language,
Okay.
and one of them is obviously Java.
Okay.
But this kind of stuff, it's just not a real world something that you never encounter in real world. You might do okay if you're just out of college, you've been doing this basically, you've been trained on this, but it's like it's very hard and it's not very useful.
Yeah.
It's not very useful in real world. So the next, so they lost that. After all of that, they lost it. The next step was apparently I sat with a guy that they have basically 5,000 people in a pool of interviewers, and they have scripted questions. And I'm like, do you even customize this for the experience of people? He's like, no, we haven't seen your resume. This is just what we do. This is scripted. You know, you just you just do that. And he gave me also this kind of an algorithmic problem of some kind. This one I totally don't remember what it was, but it took me basically 45 minutes to solve it. And the guy said that I'm not fast enough, or he didn't say it, but after the interview was over, I got an email that your services will not be required at Amazon, basically.
Mm-hmm.
So I was not good enough for an Amazon coding interview. The only thing is, I believe I solved this problem correctly, but it's not. I wasn't fast enough,
Mm-hmm.
I guess, for them. That's what I figured. So so there was a no from Amazon. And then I have some other I had some other leads in New York that I followed through. Also, like half of them required some kind of coding test, which I'm like I can't do this too many times, right? It just drains you to no end. And the other interview I had was the it's a web page, and they ask you a question, and you have to record your answer right on the web page.
Okay.
So that was kind of interesting. I did that. I heard nothing back from those people. I heard something from one company in New York, and they basically wanted a what's in the U.S. I'm not sure what it means for international audiences, but in the U.S. they wanted uh, a personal 1099. No, I'm sorry. It's an hourly W-2 with no benefits, which means you're paying 50% taxes, which is kind of high in the U.S. for the amount of money that we're offering with zero benefits and zero way to deduct any of your taxes. So I'm like, I couldn't, I said, no, I just can't go through with this because I'm losing my health benefits and not getting much in return. So I said no to that. And by the time all of this has concluded, I was able to schedule an interview with Payara because they have like it used to be that I interviewed with the CEO. Now they're a little bit bigger. They wanted me to interview with the product manager, the project manager, which I did that, and so I accepted I accepted an offer to go back to Payara. So that's how I wound up back in Payara right at this moment.
So what do you do at Payara right now?
Okay, so I used to be basically Java developer. Now they have me in a role of test engineer, which is improving testing and QA and continuous integration and DevOps and all of that stuff, which is good for me because I haven't really dealt with any of that stuff on a professional level before. I just installed Docker recently. I was avoiding that because it's on a Mac. It's not that great.
Actually, on Mac, it is easy. I mean, if you install the application, then you can use your command line and it just works, right?
Well, it is easy, but it requires a Linux virtual machine, so it's not very fast.
Yeah, okay. It's fast enough. So my machine, it is really fast enough, right? So it's not like if I launch Payara on Docker, on Payara outside Docker, it's not a huge difference on my machine.
Are you on a Mac?
Yeah.
Yeah, you must have some new Mac. My Mac is like 6 years old, so maybe
mine is, I think, 2 years old.
Yeah, there's a difference.
Mm-hmm.
But it does work. You're absolutely right. It works just fine. Yeah, but it just this is good for me when I did this whole to do to get back into testing and what the current state of testing is. As a matter of fact, I submitted a whole bunch of bugs and issues and PRs to Archillion because now I have to deal with that kind of stuff. And I know you don't use Archillion too much, but with Payara you have to because that's the only way to test Payara itself, right?
Mm-hmm.
So Archillion is a good way to test Payara. Also, like dabbled in test containers and JUnit 5 and all that kinds of good stuff.
No more reactive programming for you, right? So you were always active. So if I did something with reactive programming, I always get feedback from you or Project Loom, right?
Well, let's talk about. I mean, reactive is such an overloaded word. I have an issue with a very small subset of reactive, which is the whole a mess of. It used to be a mess of callbacks. Now it's a mess of completable futures and lambdas and all that stuff. And it's like, oh, I want to have reactive JDBC. Even Oracle doesn't have reactive JDBC. So in my view of the world, Project Loom is going to change that part of the reactive, which I don't like, which is the whole you can never block type of thing.
Yeah.
When
I'm with you. So the reactive programming, I would say, makes only sense if you have reactive data sources. So in my current project where we use Kafka, it is just natural reactive because you have like a stream of events which sits somewhere and you can subscribe to that and you are done. Which reactive doesn't make any sense. This is what happened, a few years ago with, I was asked about reactive programming, and what they actually wanted to do is, to combine JAX-RS synchronous calls to something to coordinate the calls, and they hope that they achieve better performance, which could be actually even true, but was never a problem in my project. So I would say reactive done right, it is simple and natural, but not everything has to be reactive. And you're right. If you now with Project Loom, if you have to build, let's say, API gateway, this would be the perfect case for Project Loom, where you will have to call, several JAX-RS resources in a sequence. You can use Project Loom and just rely on programming as we know, like just calling, the method, and don't care about anything, and it will be fast enough with the Loom-like green threads, right?
Exactly. That's the whole thing. If you are doing naturally reactive stuff like listening to Kafka, listening to JMS, anything that basically anything that reacts to stuff naturally, that's perfect. That's great.
Yeah.
But when you're talking about converting your imperative programs into reactive just because you think it's going to be slow, like just instead of calling service orchestration is basically one thing. And it's a perfect example that you made. Service orchestration, yes, in today's world, if you're Netflix, you need that. But in looking 2-3 years from now, even a year from now, I think Loom is going to be at most 2 years. I think they're very close to being done. So if you're like writing code that's going to be alive 2 years from now, and you think you're going to be in Netflix 2 years from now, there's no need for any of this callback or lambda hell or anything, any of this what I call like fake reactive, which is reactive for the sake of, oh, maybe this won't perform well, like if I become Netflix type of things. There's no need for that because Project Loom is going to fix that. And the great thing about Project Loom is that very few things are going to need to change if you are doing things as you're doing them today.
Yeah.
Just do things as you're doing them today with Jakarta EE now and microprofile, and it'll perform just fine. You just plug in Project Loom and it'll just work, and you don't have to change your code, which is perfect.
Yeah. This is how it should be. This is but I would say this reactive programming was a little bit excitement, generated at conferences, very similar to AOP, aspect-oriented programming. Also, even it was 10 years ago. And
Yeah.
I think recently I spent some time in a code review in a project, and they use actually Spring with AOP. So I used this AOP the first time for ages, and it felt really ancient. So they did stuff with cryptic syntax just to have aspects, which we could now easily do with annotations and for that what they did, just interceptors would be enough. Yeah.
Yeah, and I also think a lot of this stuff comes from JavaScript, because JavaScript that's the only way you can do things, right?
You mean what, with AOP or with threads?
They like the callbacks and the quote unquote reactive programming.
Yeah, the callbacks were there were callbacks. Then the solution to the callbacks were so-called promises, which are very similar to Java futures. So it's not a real problem because you still is ugly. And the recent JavaScript introduced something where it's similar to asynchronous, what we have in Java EE 6. So you can, or even 5, Java 6, I think. At asynchronous, you can annotate, EJBs with asynchronous, and this is in JavaScript called async. And if a method is async, inside the method you can use await, and this looks like Java. So you are actually, the entire method becomes asynchronous, but inside the method you can work with the functions as if this were request response functions, which is similar to Loom. So I would say that the great thing about JavaScript, if you have Java programmer, and you can ignore all the JavaScript frameworks and just use vanilla ES6 and then program like Java right now.
Right. All I'm saying that this whole hype about everything needs to have a future and callback and all that stuff, I think part of that comes from JavaScript prior to what you said.
It came
right?
earlier. So before JavaScript, in Java there was a framework called Akka. I don't know whether you remember, AKKA, and it was prior the promises in JavaScript. And I remember.
No, I understand.
Yeah, and lots of conferences, people wanted to have the Akka was very very popular back then. I have to look it up when it actually was. And what I remember, in some projects, developers use Akka, and they ask me, how to debug the stuff, because the problem was the messages overtook each other, and it was hard to debug. And I asked them, why you use Akka at all? I mean, I don't see any reactivity in your business logic. Say, yeah, but because They were at the conference, right?
Exactly. So I think that's all part of that, but I think the whole like the hype came from the JavaScript land. That's my guess. Again, I think that's what happened. There was already like the hype before, but I think JavaScript, because a lot of people use callbacks in JavaScript, they're like, oh, Java needs this because, there is this perceived performance problem. Uh, so I think that's why it became so popular and so hyped up, part of it. Uh, but now with Project Loom, with Project Loom on the horizon, I think it's going to be a shift back to imperative programming and request response
It
and
was really
all that.
prior to that. You know why? Because it came with Netflix. So the reactive programming prior to Akka, it was RxJ. This was reactive Java, and this is when it started. So
Right.
Netflix came with this RxJ Java, reactive Java library, and
Mhm.
and then it was applied everywhere else, and Akka was the next framework. So RxJ was the beginning, and let's take a look. RxJ, Netflix, and this is how it became so popular. And I see already reactive programming in the Netflix API from 2013, but it was not the beginning. So I found the article, which is already 7 years old, and it is
Right.
obviously prior to JavaScript 2015, which introduced promises. And back then, it was callback hell in JavaScript land, so
Right.
you couldn't just use it. And now we have RxJS, which is part of Angular, for instance.
Mm.
Where is the pointer to, let's say, RxJ GitHub? I think they have. What interests me right now, there's reactive X, and there should be reactive Java, Rx Java, not RxJ, Rx Java.
Good job. I
Yeah,
figured that's
and there were 245 releases, and would be interesting to see one of the first releases, but I'm pretty sure it is prior to 2010 even. And
well.
mhm.
Well, fortunately, with Project Loom, you won't have to worry about any of that because, oh, and I have to mention back pressure because everybody is like, oh, what about back pressure? With Project Loom, most of the back pressure is going to get solved naturally because you basically won't be able to queue up too many things because you're going to be imperative anyway because it just the things are going to have the things are going to wait naturally with Project Loom. So your people are going to say, oh, what about back pressure? With Project Loom, for the most part, for 99% of the cases, it's not going to be an issue.
Right. And if you have micro profile with back pressure, we could still use the bulkhead pattern where you can say no more than 5 threads. It should even work with Project Loom because Project Loom should work under the hood, not, should not be
Yeah.
exposed to the upper layers.
Well, you can't say 5 threads because with Project Loom, you can have a million threads with no problem.
Yeah, but the 5 threads is not like, what they actually mean. Not threads, rather than there should be not 5 parallel transactions. This is what I mean by that.
Yeah, five native threads.
Whether this is no one thread or 50 threads, I don't care. I just would like to have 5 users at the same time in the system, right?
Exactly. So the bottom line is that back pressure is not an unsolved problem with Loom. It's people are thinking about it. It's been solved. So it's not going to be an issue.
Mm-hmm.
I mean that's basically my spiel on Project Loom. It looks complicated. It's complicated on the JDK side, but I think they figured all of this stuff out pretty well. On the user side, it just simplifies things tremendously.
Yeah.
You don't have to have all your libraries converted. It's beautiful.
Okay.
So related to this, on my downtime after my back surgery, I actually before as part of looking at Project Loom, I tried to figure out how to do this new algorithm called chunk.io to figure out if I could improve performance on something like Grizzly or Undertow by using this algorithm. And the one thing I have to say is it failed miserably, but it's great. It's great that it failed. I know what not to do, and I know that this kinds of algorithms don't work properly, and it's perfectly fine. It's a learning experience, and what I want the listeners to get out of this is don't be afraid to experiment, even if it.
So what you did exactly with Chunk.io and why it failed?
Okay, so you know how when you have a million sockets, you're trying to create like a hugely performant web server, and you
So
have a
with
million
Nio, so
sockets.
what I remember what Grizzly did is you have one, so it is handled by the operating system, and you get a kind of a key or handle back, right, which you have to maintain. And this is your, how it's called, key or handle, and this you have to manage
Key
that.
selection, it's selectors.
Selectors, exactly, and you have maintained them. This is actually the challenge. What also the Grizzly author, I forgot his name. This was the Canadian guy. Uh,
I think it's Alex something.
yeah, from Grizzly team, from Glassfish team back then,
Brian. There's
and
two of them, Brian and Alex, I think.
they spend a lot of time optimizing, because you can get memory leaks easily back,
Mhm.
and you get the selectors, and the selectors is you get the association between the thread, or how to call it, no more thread, like the parallel behavior or process with your socket, right? And you have maintained by yourself. So what you did exactly with that? So what you
Yeah,
implemented Grizzly from scratch, or you tried to optimize Grizzly? What
I
Grizzly
tried to.
is, this is the origin web server from Glassfish, introduced, I think, in Glassfish 3, which made the
Mhm.
Comet style communication possible back then, which was revolutionary, because with
Mhm.
Comet, what you could do is like WebSockets without WebSockets. So you could push back messages to the browser.
Right. It's basically full duplex persistent I/O channels, basically WebSockets. Yes. So the way Grizzly works is it's got a thread, one thread that handles all the socket I/O.
Mm-hmm.
Basic. You can have more than one, but you can, let's strip, for this conversation's sake, let's strip this out. You have just one thread handling all the socket I/O. So
The first question: are they so-called acceptor HTTP threads on in Payara? Are these threads? Is this exactly this or not?
Payara uses Grizzly, so yes.
Yeah. Okay.
Um, so for simplicity's sake, let's say we have one thread that deals with all the sockets. So it accepts, it pushes it, pushes it back, then it returns it, processes it, blah blah blah. Perfect. So so it's all non-blocking. So my issue is that with non-blocking is uh, that when you do non-blocking, you have twice the work. One is to read or write, and two is to issue that call that does the select, that figures out how many descriptors are available, which ones are available, what they are, communicate that into the application program, and then the application program has to decide to say, oh, this one's available for read, let's read that. And when you issue the read call, the operating system has to do the same thing all over again. Here's the socket, is this available? If it is, here's the buffer, put it in, blah blah blah. So my hypothesis was that all of this doubling of the work could be eliminated if you use just blocking I/O, but limit the amount of data that you read. So what that does is, instead of doing non-blocking and then read one and then do a select and read, do a select and read, what you would do is just do a blocking read from multiple threads at the same time.
Mm-hmm.
And the solution to the problem of you're going to have a million threads is that if you chunk the I/O in the exact size of the actual buffer, the reads are going to happen immediately 99 out of 100% of the time. So your threads, even if your threads, which you're obviously going to limit to like some sort of a reasonable value, are not going to interfere with the parallelism. So you're still going to have that parallelism and scalability that you want, but instead of using non-blocking and selector loops, you're going to use multiple threads to achieve the same thing. So what I found out is that if you scale this past about one thread per CPU, basically, if you have a 4-core machine, if you scale this past 4, which this algorithm requires about 100 or 200, it still works, but the performance goes down and not up. The performance goes down to about 60 to 70% of the non-blocking. It's not horrible. It still works, but it doesn't improve performance, which is what I was looking for.
Yeah, but the question is, how much can you achieve, let's say, on a 4-core CPU comparing it with 4 threads, with chunked, comparing it to 1 threads with NIO?
Oh, I'm comparing 4 to 4. I'm not comparing 1 to 1. I'm comparing apples to apples here. I just said 1 as far as simplicity is concerned. So if you compare
but it's
apples
an unusual configuration to run Grizzly with on 4 or 4 threads, right?
Well, I'm not just trying to run Grizzly. I'm trying to get a real world test. So there's actual processes behind it that do some kind of dummy calculation.
Okay. So if you compare it 4 to 4, what was the situation then?
Yeah, 4 to 4, apples to apples comparison. The chunked IO algorithm was doing about 70% of what the non-blocking algorithm was doing. And I was expecting orders of magnitude higher.
Yeah, and I was expecting the same performance. I'm stunned that there's a difference.
You're talking about 4 threads.
Yeah.
It was the problem is you can't have 4 threads in the chunked IO algorithm because it's not enough threads not to have some requests have unreasonable latency. It requires at least 10 times the threads the amount of acceptors. Okay, there has to be at least 10 times the number of threads as they are acceptors. So if you have 4 threads, if you have 4 acceptors, you need 40 threads.
Yeah, in your chunked algorithm, right? And in the Grizzly way would be 4 threads.
That's right.
Okay, so 40 to 4, and then you got the performance was like 60 or 70%, right?
Yes, in a case that would actually work and be scalable, I was expecting like 5 to 10 times more performance out of the chunked IO, and unfortunately, what I found out is that the thread contention in the kernel just kills any of the gains that I thought were possible. And the only way you find this out is by experimenting. You just can't find this out by theory. You just can't do it.
What would be interesting, now your experiment with 40 threads on Loom, whether there will be any difference.
With Loom, you don't even have to have any of this. You can just do it in an imperative way. You don't have...
what I'm saying, because the threads don't matter, but you will still need, a way to fill your buffers, right, with some kind of parallel behavior, however you call it. So it'll be interesting, your chunked IO experiment on Loom.
Well, the way I'm imagining that we would work on with Payara when Project Loom comes out, we are deciding to support it. All we need to do is switch Grizzly from native threads to the Loom virtual threads, and that's basically 99% of the work.
Yeah, this is what I understand. But right now you have working solution with, let's say, 40 threads chunked IO, which are comparable to 4 threads Grizzly. So if you use the 40 threads switching from native to Loom, this would be interesting what happens then.
Oh, no, you have to have 40 native threads for the chunked IO to work.
Okay.
You can't use Loom threads at all, in this, because you'll have unreasonable latency at that point.
And you already used the rewritten, I think, datagram socket from JDK 15 or 16,
Yes.
You use that or older IO APIs?
Well, we're dealing with the TCP sockets, and what I actually had to do to make all of that chunked IO stuff work, I had to basically rip out, when you create a TCP socket, when you do a read and write, JDK under the covers does its own, like it switches the socket from blocking to non-blocking and vice versa, does its own little select to figure out whether there is anything in the buffer. With chunked IO, I didn't need any of that. So I had to basically make a module that plugged into the JDK itself to basically rip all that code out to have plain reads and writes to just do socket reads and writes under the covers, as opposed to doing all the stuff that JDK does ordinarily. So it was kind of interesting, and JDK 8 is different than JDK 16 because JDK 9 introduced module path and all that stuff. Boot class loader disappeared, so all that stuff was it was a very interesting experiment.
And what was worse? Was worse the performance or throughput or scalability? So what was your actually idea, that you can run more concurrent application, or single thread or a few threads faster? You know what I mean? So it is like
Yes.
you search for solution for an API gateway with millions of users, or for Payara to run faster, just.
Well, the idea was to increase throughput by orders of magnitude.
Okay.
Uh, without increasing latency latency to unacceptable levels. So there would be a trade-off with latency. It's 100%, but not in the worst case scenario. On an average case, latency should stay the same. In the worst case scenario, there could be increased latency for some connections,
But
and that's part
if
of
you
the
had
algorithm.
machine with 40 CPUs, what's
Mhm.
then? Then it would be faster?
If I had a machine with 40 CPUs, would it be faster? It would be the same. I could not get it to run any faster.
Okay, because it would be interesting. So use chunked IO with as many threads as CPUs comparing to Grizzly.
Yes, and it's the same. Unfortunately, again, the worst case latency is increased compared to Grizzly, so it doesn't make any sense to do.
Okay,
That's
so
unfortunately
it was
that's the,
not like a hardware problem, it was more algorithmic problem, right?
well, it's the way the algorithm works, and it's not a fact that it's not a matter of fact that you could redo the algorithm to make it better. It's just that the way that modern systems work and the way the non-blocking I/O has been optimized up to this point. I tried this experiment before. The first time I tried this experiment was about 12 or 13 years ago in C++ land, and it actually worked. But today, the kernel and the ecosystem around it increased. It just improved a lot at this point. So the operating system is optimized for exactly this type of I/O that Grizzly does. And right now, there is no advantage because the operating system and all that stuff has been improved.
What would be interesting to try the same on the Apple M1 chip.
Interesting.
You know what M1 chip is?
I know that they're coming out with that, and I know that that's going to make me buy a new computer.
So what it is already out, and the stunning stuff is this M1 chip from Apple is some ARM-based architecture, and it costs the same as the entry level Macs. Actually, it starts with 800 euros or something like this, roughly, or
Mhm.
dollars. And the why it could be interesting, because what they did is they have one memory for everything. So the RAM and GPU and everyone sees the same memory. So it is very fast to read and write from memory. And maybe this changes, the situation. So this, no idea, but it would be just interesting, to see how this behaves on M1 chip, because this ARM is kind of future, because Apple runs on M1. The AWS has their own ARM Graviton chips, CPUs, and ARM seems to be an interesting idea. And the architecture is different, so it could behave differently, right?
It's an interesting question. Project's still around. Does the Java runs on it?
Have you
Run?
open sourced the project somewhere? GitHub? Or?
No, I did not. But it could easily done. It's under Git, so I just push it to GitHub.
Yeah, it could be interesting, man. Why not? Probably the community could, experiment with it. And
Speaking of community, I had the toughest time getting a PR into Hazelcast. Hazelcast, if you're listening,
yeah,
merge my PR, please.
okay. What you did with Hazelcast?
I had a long, over 3 years, outstanding issue with integrating Payara with Hazelcast because Hazelcast assumes, single application with no class loading. With Payara, what happens is if you start using Hazelcast feature, you unload and reload your application, everything breaks because Hazelcast caches the old classes and the old class loaders.
Mm-hmm.
So I'm like, like people are in Payara customers are starting to use Hazelcast, and they're like, oh, we're getting weird issues and this class loader problems and all that stuff. So I was kind of so that required a PR to Hazelcast. So I wrote it. The Hazelcast people didn't like it, so I had one guy rewrote the whole thing, and now I tested on Payara side, nothing works. So I fixed it all up. I went in, resubmitted it back to Hazelcast, and then there's another guy who doesn't like something else, and it's just like it's going through an endless review that's lasted over 3 years now. So
Okay.
I'm kind of upset, as you can
Okay.
imagine.
Okay.
So
So
it's just
this is
really
this was your also leisure project or one of your your commercial involvement with Payara?
well. At first, it was a Payara project because it was customer complaints, and then
Okay.
when I didn't work for Payara anymore, it that project, customer project, didn't make it or something like that. Uh, so they're actually pretty big Payara customer. So the project doesn't mean the Payara didn't work out, but one of their project that required these enhancements didn't work out, or they decided to do it some different way. So it wasn't a problem for them anymore. So, but there are some people who are uh, not customers that I know of who were complaining about the same issue. So when I was not working for Payara, it became a leisure project, and now that I'm working for Payara, it became another professional project again.
Okay. If you can talk about it, where Payara is going, what they're hiring a lot of people. So, and what is the mission of Payara? Where are they get the mailing list with cloud native or whatever? So, do they have you can talk about that, or should I invite Steve Milic again?
No, no, sure. Actually, that was one of my questions. Can I talk about this stuff? Well, the one big change that Payara went through while I was not at Payara was Payara Enterprise.
Mhm.
So, uh, so now Payara has two versions: Payara Community and Payara Enterprise. They're both open source. They're both available. The difference is that community is, got the latest features and the new stuff that might like basically go fast and break things. We're trying not to break things, but things do get broken. So we try to move community fast. But when things are stable enough in community, we migrate them to enterprise. And also, in enterprise, they monitor, like a lot of different monitoring features are built in by default, so you don't have to go and get them and combine them and make sure they work together. The enterprise basically, it's a stable version that works basically kind of like
Yeah,
Red Hat Enterprise distribution.
yeah, but I mean that's that is just the I would say commercial support strategy. But
Yes.
what they are doing beyond Jakarta and microprofile, this is the interesting part because
Okay.
what is the
So there's
added value, like the Hazelcast, or I don't know whether they have specific cloud integration or whatever.
Okay, there's so many. Uh, Hazelcast is one of them. If Hazelcast, when I hope Hazelcast merges my PR, we're able to do full Hazelcast integration. That means all of Hazelcast is available in Payara to use, which means caching, distributed maps. I'm excited about distributed locking. I don't know, maybe call me funky, but I love distributed locking. Like things like you have a cluster and you want to pick a leader. Hazelcast does that.
Yeah.
So Payara has that.
Yeah, this is the replacement of Zookeeper. Usually, the leader election, something like this, would be the job of Zookeeper. And if you can do it with Hazelcast, yeah, if it works.
Yeah, and Hazelcast is really well designed to be scalable because they have this partitioning schemes where basically distributed throughout the cluster, and there's like real-time backups and real-time performance, the routing. So when you go to get one object and there's too many people are getting to that one object, it splits it automatically into different nodes. There's a lot of these enterprise features in Hazelcast that you don't even think about that are fantastic and then can be used pretty much directly in Jakarta EE and microprofile applications on Payara. So that kind of stuff is exciting to me. The other thing that's exciting to me is Payara Insight, which is basically cool dashboards around microprofile metrics and internal Payara metrics, which, by the way, Payara is exposing more and more metrics to microprofile in order to do this whole Payara Insight thing. It's if you go on YouTube and look at Payara Insight and look at the video, It's actually quite amazing. It's actually I know you talk about useful metrics, Adam. This is exactly that.
Mhm,
Useful application metrics, exactly what you're talking about.
mhm. Yeah. So what happened already a couple of years ago? So Payara always exposed a lots of metrics. This is actually one of the reasons why I use Glassfish. Um,
Mhm,
I don't know, 10 years ago.
mhm,
Started a Glassfish V2 or V1 even because they
mhm.
always had a great admin console and metrics. And what you can do with Payara right now is you can choose, one of your JMX metrics and expose them immediately to microprofile. So this is also nice because you can say, okay, I would like to have this in this JMX metrics. You have to write an XML snippet, and then it's available in as a microprofile metric, which is really useful.
Right. The other awesome feature
And by the
that
way, this insight is really nice because usually you would need Prometheus and then Grafana to visualize the stuff. And
Mhm.
sometimes it's really nice to have, the visualization in place because you don't have to use to curl the matrix or try, to parse them as a JSON.
Absolutely, absolutely. This is just pre-built tool for you that you can use immediately, and it's very pretty. It's very nice, and it's very useful. It's not just pretty, but it's pretty and useful,
Mm-hmm.
which is hard to do.
Mm-hmm.
Hard to do. The cool new stuff is the Payara Cloud.
Mm-hmm.
So you know how you always talk about why isn't there a place they could just upload WAR and it works? Well,
Mm-hmm.
this is it. So
Oh,
you go, you create an account, you upload your WAR, it works. Period. Done.
that is actually great. So this was not Payara Cloud. You should call it serverless, which is a little bit hard for Payara server, but this is actually
Yes.
serverless.
Yes. This is exactly what it is.
Because for me
Um,
it was always, the I never got the idea why, for instance, lambdas are so special. Because if you have creating, AWS lambdas, you have to submit a zip, or you had to submit back then a zip to the Amazon lambda, and then function was called. It's like, but if we submit a war to an application server and a JAX-RS thing is called, then for me it's almost like lambda, and
yes.
it really is. And for instance, right now in a Quarkus application, you can package as a lambda and ship it to the cloud, but it still is a JAX-RS resource. And the Payara Cloud, if Payara Cloud allows you to submit a war which gets executed, this is actually a great news because this is like serverless. You don't care about the servers. This is what serverless means. It's not like there are no servers. It means I don't care about the servers, and I can just submit the wars. And I think how many Payaras are started in the background is the matter of the Payara Inc. I don't care about that, right? I probably can
Yeah,
scale less and more and pay less and more, but I just care about my business logic, right?
exactly. That's been designed with what you are always what you're preaching in mind, which I agree completely. This is what it should be. I don't want to set up the environment, even if it is as easy as creating a Docker image. I don't need to do that. I just want to upload my WAR and have it run. Period.
I would have to try it. So I would try, to get an account and
Yeah.
just because this is what I never got from some microsystems. So back then they already had, the application servers, the wars, and the ears, and they've the Sun's Grid was like the first cloud, and you had, to some package Java code with a zip and ship it to the cloud. It's like I was asking myself why they don't use wars. I mean, this would be so simple, and they missed the opportunity. So I'm glad the Payara is doing this right now.
Yeah. Yeah. Exactly.
Are you involved with Payara
So
Cloud somehow, or you are just testing the cloud?
I I'm not directly involved,
Okay.
aside, as you said, from testing the guts underneath, make sure that works. Because that whole initiative took place when I wasn't around. But you, a lot of if not all of our developers listen to the podcast and kind of agree with lots of things that you're saying.
Okay.
You're actually you have some some influence with how Payara is developed.
Oh, Nice. So I will invite someone from Payara to talk exclusively about the cloud because, the impression I saw the Payara cloud announcement and I expected there is something else that they created some more integrations, with, let's say, Kubernetes. Okay, what this could be, I don't see, the opportunity. But what sounds to me that the Payara cloud is like the managed Payara by Payara in some cloud. And this makes a lot of sense. This makes actually a perfect sense. And what's interesting, there would be another revolution, right? So what I consider a revolution like Quarkus, which completely, it is micro profile with a little bit Jakarta or Helidon, and it behind the scenes happened something different. So Payara, what they did right now is Payara Cloud is similar thing. Is they say, okay, we take the server, don't care about the server, push your business logic to us, and we'll manage for you. So it is also a huge step forward, I would say, where it makes absolute sense. Mm-hmm.
Yeah, absolutely. The other thing I want to talk about is, Quarkus and Helidon, I believe they will have their place. However, even if you're running new projects, basically, the truth is that Quarkus does not run Jakarta EE. And Payara does, and there's just no way around it. However, Payara also runs on GraalVM in, obviously in JVM mode. It does not run a native image, but it does run on GraalVM just fine and performs just fine. And yes, Payara doesn't have those reflectionless startups. But again, and I think you said on your last podcast, it's 3 seconds versus 1 second. Do you really, really care if you have to rewrite your apps?
What I'm searching for are killer use cases where we cannot argue about that, right? So, for instance,
you can always argue, then that's fine.
Let's say the Payara cloud, let's say Payara serverless cloud, is a killer use case for Payara right now. If this really works, why? Because only with Payara or application servers you can have thin wars. They are technically impossible with Quarkus or Helidon, because Quarkus and Helidon, they already have some pieces of the framework, which they are not meant to run as a serverless application. They are meant to run well in container. But if I push a war to the cloud, I use the war as a first, first choice deployment format. And I don't care about containers at all. I just push, my business logic to the cloud, which only knows API, Jakarta E, and microprofile, which is impossible to achieve, with Quarkus and Payara. But if I run the entire stack, then with Quarkus or Helidon, it's a different story, because then where Payara shines is shared deployment, which makes perfect sense for the cloud, and where Quarkus and Helidon are better or optimized for is one-to-one deployment, which doesn't make any sense for cloud or serverless and makes more sense for single applications. So the interesting part that we see right now is that the Payara becomes, the runtime for the cloud, and Quarkus and Helidon become the microprofile runtimes to ship applications. This is a complete different approach, which is both are interesting, I would say.
Yeah, sure.
And in Payara, if it really, the Payara cloud is like a serverless, it doesn't matter how long it starts, because it is started by the Payara company once a year. I absolutely don't care about the startup time, and I also don't care whether you're running GraalVM or what. I don't care. I just ship my war to your cloud, and I'm happy, right? But if I run Quarkus or Helidon, I absolutely care about everything, because I'm in charge of building the cloud. So I will have to buy ECS or Azure instances or whatever cloud and manage this by myself. So then this is a completely different use case. So I have to care about startup times, memory, CPU, everything. And so I'm really, stunned about the idea that you could actually also I said it multiple times, but this is the idea is not the problem. The execution is the problem, right? So if you have your own Payara cloud, this is interesting. So really interesting, and even support costs are different, right? Because you can say, okay, support doesn't matter anymore because the Payara servers are patched the entire time by the Payara company, right?
Yeah, that's absolutely true. Oh, one more before I forget. I want to shout out to OmniFace's team. You guys are doing a great job. I just completed a round of patches to or additions and enhancements to OmniFaces to improve it, and I had a very productive 3 weeks or 4 weeks with Boak. I hope I pronounce your name correctly.
Yeah, this is the number one guy from Stack Overflow who cares about Java server faces, right?
Yeah, exactly.
I think it's Bauke is his German name, I think, right?
Yeah.
And Arian Times is the other guy who's the Java EE 8 security hero.
Yeah, and he does a lot of stuff for Jakarta EE
exactly
as well. So big shout out! Thanks for working with me on accepting my JSF utility library into yours and combining the efforts, which is very very nice. So JSF lives on. JSF is maintained, and it's Prime Faces. Also, I want to shout out to Prime Faces to Shatai. That we love you guys.
Yeah, perfect. So Lenny, where people can find you, or do you still have Twitter, or you got your own personal Payara?
No, I still have Twitter. LPRIMAK, Lprimac on Twitter. That's one of the ways. I get a lot of spam emails, so I'm sure my email is all over the internet if you look for Lenny Primac. I'm on LinkedIn also. I've been more active on that since my brief job search. I'm now looking at LinkedIn as well. Basically Lprimac is on all social media is where you can find me.
So basically, what you learned from your experience as a applicant to different companies is basically means if you're a developer, don't apply anywhere, right? This is really except Payara. But
what I've learned is that if you are not just out of school and know all your algorithms and the big O notation left and right, and you can write your own binary search tree, or you use the cottage industry that's there to learn how to pass these coding interviews.
Exactly.
Don't bother going to at least Amazon.
Yeah. Then no. This is what I already knew is you will have to cheat the system. So what you mean is you will have to prepare, just for the interview to pass the interview by learning stuff who no one needs actually, or I mean you barely need. The B tree is interesting if you're building a database, but not really if you are enterprise or Java programmer. So this is the sad story, which is like it is, because I think no one of pragmatic Java developers will ever pass such an interview without preparation, I would say.
Exactly. And preparation means really sitting down a few hours a day, at least like 3 or 4, for about 2 months to figure all that out. Because all these
what I think there are portals or website, for Amazon and Google interviews where they know already all the questions, so you have to go through the questions and do it. What actually back then the Java certified programmer was the hardest one, and there were books about the questions. This was exactly the same cheating for me, because it's, if you just learn to answer the questions, it's not like you are a certified programmer. You are certified questions processor. For the certification, it's a complete different use case.
Speaking of useful programming questions, I have one for you. Did you ever have to deal with final transient field in Java serializable class?
No, but what do you remember me is I did some experiments with final synchronized, because back then and servlets you could you could improve performance of final methods. Final methods, yeah. Because at the beginning of Java, if method was final, it was faster because the JVM knew there is no polymorphism in place. So back then I did some experiments with it, but not with final and transient. What final and transient in
Well, let me give
serialization?
you a specific use case. How do you how do you serialize injected services, injected singletons to be exact? Obviously outside of Jakarta EE, which handles them directly.
You mean injection outside Jakarta? You need a kind
Yeah,
of container. The problem is if the injected thing is a proxy, it's probably not serializable. And whether it's a proxy or not, it depends whether you used the Jakarta E or microprofile services or not. Because if you inject a singleton, it is probably not a proxy. But if you inject a singleton, which is transactional, it is a proxy. And then this serialization is probably, this proxy is not serializable.
it is. Actually, in the Jakarta EE side, it all works. It all works correctly because the proxies are serializable and they're handled correctly on one side and the other. That's
Yeah, but the
good part.
yeah, okay. You're right, because in Jakarta E, if the application scoped or the singleton, it has to be serializable.
Yes.
Because then the proxy is serializable, because the proxy will implement the serializable thing. And wait a second, where are you going with it? Because if you inject something into, you get the error, right? You get the error that the injected class has to be serializable. So when it happens in JSF? Because
No.
if you put
Yes, you're right.
If you inject something to session scoped, right?
View scope.
Yeah, exactly. This is what then the proxies are. But you said outside of Jakarta E, right?
Yes. Yes, outside of Jakarta EE, because if you're inside Jakarta EE, the injections are handled for you.
Yeah. And
So,
outside, what means outside? You are in Arcadian, or what is outside?
let's say you have you have a non-serializable object. You have many non-serializable objects that you need to use in your serializable class, and that's why you make them transient, because they're not serializable.
Yeah.
Right? So how do you handle that? Because when you deserialize that object, all your transient fields become null, right?
Yeah.
When you deserialize them, they're null. But if they're final, you can't initialize them because they're final.
Yeah.
Okay?
Yeah.
So that's the question. How do you handle that?
Constructor injection, right? Is the only thing you can do.
No injection. That's not available to you. That's part of the question. Outside Jakarta E.
Outside Jakarta E. So what do you mean? I have to have injection without injection? Then you can implement two methods. I forgot the exact names. They are like magic methods. They are in the serializable Java doc.
Yeah. Read
the external and write external. I think that's the name of the methods. And you can
Can't do that because that requires initializing your transient variables, and you can't because they're final.
And you could implement externalizable interface where you have the complete control over serialization and deserialization.
That's not the scope of the question. That's not in scope. Can't do that.
Okay, you can't do that because you cannot implement the interface, right?
It's like just let's say the question says you cannot use externalizable.
Okay.
The class is serializable,
okay.
and you can.
Okay.
It's not removed.
Then in serialization, what I remember is that this is a strange way how the constructor is called by the deserializer, right? Yeah, deserializer, and
yes.
You can do something. You can execute code during the deserialization, which is a security risk. And with that, you can probably do whatever you would like to do because you could then set the fields. This is what I suppose.
Okay, so this is where it comes down to. You cannot set the fields because they're final. Yeah. When you deserialize the object is already created. when you use those methods, the magic methods, you can't set the fields because they're final and they're already null, they're already set, they're already null. You can't serialize them. The answer to this question is there is another magic method that's called read resolve, which nobody knows about. However, what that does is lets you create another object to put in place of your object that's already been deserialized. So read resolve will return new of your object, but here's the trick. The trick is that let's say your object, your serialized object, has a lot of state, okay? And the state could be recursive, could be deep. You don't know what it is, right? That's the whole problem. So the issue is, if you use this read resolve method, you need to recreate the class with all the states that's already been deserialized. And the only way I know how to do that in a reproducible and easy way is with ding, 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 Project Lombok, because it's got a builder pattern with a to-builder class. So all you got to do is, in that read resolve method, you could say to-builder, and it'll just give you, to-builder.build, and that'll return the exact copy of your class that's been deserialized with no other boilerplate.
So you are back to, this is why you like Lombok, and
yes,
I still not convinced. I mean, we had a discussion the last time. I always ask myself, what happens if the two Lombok guys lost their, interest on Lombok?
I have an answer for you. There are actually 17 committers that have pushed PRs into Lombok. It's not just two guys anymore.
If you search for Lombok on GitHub, this is not entirely true. Lombok GitHub. Let's do this. I will put it to show notes, Lenny. What I would say, what I expected is, I say, if they lose their interest, I would take over. So this would be my.
Yeah, I might. I don't know, but
if you go to the Lombok is the Switzerland is the organization Lombok, and you search for commits, you will see that the two guys, Spilke and Switzerland, they have a lot of commits, and the number 3, almost nothing. There are lots of contributors, but they are inactive. You have to do this.
When you push a PR, the PR is under these two guys' name, but the people who actually built the PR are not.
Okay.
At least that's what I'm thinking. Yeah, it's true. Even though the commits are by these two guys, they're committers, but they're not the contributors of a lot of those PRs.
That's what we show. Yeah, this is one PR. You are right. Just one PR, one PR, one PR, and then lots of commits. Yeah, but I would say more than 50% comes from them. I just look at the commits right now.
That is true. I agree with you there 100%.
And this is why non-issue for you. But I'm asked about my opinion about Lombok for larger projects, and this is no more that easy, because if I say yes, they will hire external consultants which will use a lot Lombok, and then if these two Lombok guys lost the interest, no one will maintain that. So this is like, my clients only have to know the facts. So I show the list to say this is like it is. Now you have to decide, and then decide for Lombok or against Lombok. But point is, Lombok is driven by two developers, and I think if you take a look at Payara, it looks way better than Lombok, I would guess. Let's see, Payara GitHub. It should be
Payara is a much larger project.
Yeah, let's see.
The other thing
let's compare Lombok to Payara. And it looks way better. I mean, there is number 1 is Pendrex, then Steve Milic was, then JB now took over, then Jonathan C was very active, Jugaurav Gupta very active. And what's interesting in Payara is, and the beginning, the Andrew Pilic and Steve Milic were very active. Now they are a little bit less active, and the others are picking up. So what it means to me, and there are lots of contribution, Alan Roth, D. Mate, and whatever. And Mark, what I'm missing is Lenny. Is somehow lazy. Lenny Primek, where is he?
Because you got to look at tests for me.
Okay. So I would say in the case of Payara, if you take a look at the commit list, and by the way, what's also impressive, the commits in Payara 2015, so it was they are increasing more and more, so Payara becomes over time more and more active. And what I see at the commit list is that the knowledge is spread across different developers, and there are at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, still 15, 16. So let's say 17 active developers, and all others are, contributed code, and there are in total how many contributors? 76 contributors. So I would say for that, right? I would say Lombok is, if you consider the entire Java community, is more popular than Payara. I would say Payara is more specialist tool, and still there are 76 contributors in Payara, and you have far more active community in Lombok, which is not very good sign for Lombok, right?
All I can say is
now we are working for Payara, so you cannot argue with me right now.
I'm not arguing. I agree with you. I agree with you on all your points. However, Lombok has a big de-risking tool associated with it. It's called dlombok. All you have to do is pay. If all of a sudden people they lose interest for some reason, Lombok is going away. All you have to do is copy and paste your little thing into your Maven file. That's called dlombok. You run it, and all your code has converted from Lombok to dlombok.
Yeah,
and
you're
then
right.
You're no longer dependent.
In your case, but a larger enterprise project, let's say one software provider does something with Lombok, and the other software provider says, I don't like Lombok. So what will mean is they will de-Lombok their code, and the second one gets a crazy amount of code, which we would probably not written in the first place. Because if I don't have dlombok, I wouldn't write, all the getters and setters, because I don't need them always. But the Lombok developers always tend to do this, that they have this complete different programming style, I would say. You are right. I look at Lombok from the more organizational perspective. From tool perspective is great. I personally don't like Lombok because it's code generator, and I tend not to like them, but I get Lombok can be very useful. We had the conversation the last time. If you have, if you need to have consistent hash code, let's say, and equals because you store the objects in a hash, I mean, Lombok is golden, right? But in my projects, developers would like to have Lombok for the same reasons like they would like to have, reactive programming, because they were at conference and they would like to try something new. And this is where I see, okay, then don't use Lombok for that.
Yeah, that is absolutely true, and that's true for any kind of tool.
Yeah,
that is.
So if you ask me my opinion about something, usually I say no. Why you need it, right? Because I learned over time as a consultant, you should not answer the questions directly. The first question should be why you need it, and I would stop with a short story which happened to me, and this was back then. Eclipse RCP project. I was actually in charge of the backend, but someone told me, okay, hey Adam, can you help me with Gang of 4 patterns? So sure, maybe. And then he asked me, how adapter pattern works, how command works, how factory, abstract factory, and decorator. And I told him, and then after 1 hour, I said, okay, what you would like to do? And he told me, yeah, I have here a button, an Eclipse RCP, and I would like to, invoke, if I push this button, I would like to invoke this method, but it has to be really flexible. And what he wrote is a framework around the button, to be very flexible, which method was actually, but the button was like okay or safe, it was pointless. And then I really thought, okay, it's actually my fault that we created the framework here and this half a day. And actually, at the beginning, I would just ask him why you would like to know it. And if say, okay, I would like to call the methods, like forgot about the patterns, just call the method. And this is why I tend, if someone asks me a question about libraries or frameworks, I always say, okay, why you would like to know it, or what's your problem? If you don't have problem, forget about the frameworks, right?
Yeah, that is very true. Very pragmatic. I'm with you. I'm very pragmatic too. I want to solve the problem. This is why when you get into these long conversation of, we better do this or better do that, I'm always like, let's back up a bit. How do you solve the actual problem? Because I always remember, I'm not in like projects now, but I'm always keeping that in the back of my mind. How is this from the user's perspective? And that's what I do with Payara as well. Like, how is this helping the user? Is this helping the user? Is this helping? What does this actually do? Is this usable? Like, what can we do to make it usable if it's not? So you just got to always pull back and see, is this useful? Is that useful? Is that really useful? You got to really look at that stuff.
Yeah, and this is also, complete different perspective. If, for instance, if you are in the Payara project and reuse for instance, or sharing code dry is very important, because from my perspective, in my project, it's less important. For instance, people, sometimes I create a small libraries, on my GitHub account, and people ask me, can we use that? So I get so sure, I mean, this is open source, but before you download the jar, take the code and take ownership of the code, because then you are not depending on me. Because who knows? I'm created some libraries and I have no time to maintain them. And if you wait until I release something, it's a risk. But if you just pick the code, you can do whatever you like. You are not depending on me. And if and this is the price of open source is not free. You will have to maintain it, the relation either to the author or the relation to the code which not belongs to you.
Oh, speaking of just contributing and not just taking, this was so funny. I remember this because I mean, I have my own library, my own utility library, which part of it I contributed into Omnifaces now. So my library started with Tapestry. Are you familiar with Tapestry at all?
Yeah.
Okay.
This was a very popular framework a few years ago. It's like it was after Struts was like one of the
Yeah. So I started using Tapestry. However, I switched to JSF because Tapestry by itself is okay, but the problem is it has its own IOC. It doesn't support CDI or any kind of, it's got its own IOC, which is completely atrocious. And every time I had to change something, I had to mess with the IOC because it didn't work or something else didn't work. So I'm like, no, JSF is better. So I switched to JSF a long time ago. This was like 2013 or 14 or 12 even, like a long time ago, 8 years ago. But before I switched to JSF, there was an upgrade of Tapestry from 5.3 to 5.4. So I tried to upgrade my project from Tapestry 5.3 to 5.4, and I created a branch. And I never finished it. And I kind of abandoned it. And it's on GitHub. So in 2020, when I did the contribution to Omniface, and I'm like, let's clean up all these branches. So I deleted the 5.4 Tapestry branch, and 2 days later, there's some guy emailing me, says, where did this branch go? I'm like, I haven't used it in like 8 or 10 years. What do you mean?
Yeah. By the way, Tapestry is still around. They released 5.6.1 in September, which is surprising. So this is,
I know.
Interesting.
It's probably got a user base, and and that's perfectly fine. It's great, but I'm like, well, do you want to take this over? Do you want to complete this branch? So he's like, no, I don't want it. I'm like, all right, I'm not going to restore it, because if you're not going to take ownership of the code, you don't really need it. So, you can't just take from open source. You got to give back.
Okay, Lenny, thank you. It was fun. And now it's always dangerous to talk with you, because now I will investigate a little bit more Payara Cloud. And see you probably, one point of future, talk about your next experiments.
Sounds good. Don't be too harsh. It's early alpha. But we welcome your feedback.
Okay. Thank you. Bye.
Thank you.